everyone, I'm Harmeet. Today we'll talk about building reliable data pipelines. And this first we'll discuss what is a data pipeline. Then we'll talk about why do we need reliable data pipelines, and then we'll dig into what, why, and how of shift left testing, and then finally conclude with a summary. So when we think about data pipelines have source data. We transform data into a target format that can be used to take some key decisions. It's as simple as that. But we all know that it's never that simple. As the pipelines grow, they have tendency to become super complex because they consume data from each other to get better insights, which is fine. But because of this complexity, we have observed that data teams start spending a lot of time in fixing data issues rather than adding value. And because of a lot of quality issues, business start losing trust in data, and that results in gradually low adoption of data driven decision making in the organization. And there's a term for that. This is called data downtime. Barmoses have given a good definition to it. She says that the periods of time when your data is partial, erroneous, missing, or otherwise inaccurate is called data downtime. And does it matter? Yes, of course it matters, because bad data is bad for your business. As per one of the researches, has been found that organizations can lose approximately around 10 to 14 million US dollars, and it can cost them around 30% of their revenues, and it's estimated to cost the US more than $3 trillion per year. So what we can do? Definitely we have to fix the quality by testing and validating, and validating and testing early. And this is what is called as shifting left the quality. Why are we saying that the shift left works? These are some of the stats from the world of software engineering. And as per this, if we find a defect early in the development life cycle, it can cost us 100 times less as compared to a defect which we find in production. So it's clearly evident that shifting left work. But before we shift left in the data engineering world, we have to clear some of the basics. So when we say data pipeline, we know that data flows from source to target. But data pipeline, apart from data, also has some code. And code flows from lower environments to higher environments. And this is CI/CD pipeline. So consider these two pipelines as orthogonal pipelines. So there's data which flows in data pipeline, and code flows from the CI/CD pipeline. And when we are talking about testing or validation, we have to think about both these pipelines, testing early in both these pipelines. So those of you who come from a software engineering world might have seen this testing pyramid many times. So just like a regular pyramid tends to be the most stable structure in real life, the testing pyramid also tends to be the most stable testing strategy. So normally the convention is that you can have 70% unit test, 20% integration test, and 10% end-to-end test. The exact mix will be different for each of the team, but in general, it should retain the pyramid shape. Now, the unit tests are cheaper and have faster feedback. So that makes it more effective, and that's why it's suggested to have more coverage in the unit test. So similar to a software engineering application, we should test the data engineering application as well and map our efforts to the testing pyramid. And automation is the key. So let's take an example here. Let's assume that we have to write a pipeline or a job which does some sort of flight analysis to generate some great insights around flight delays. Now, as a data engineer, when I start writing that application, I'll start with smaller function. Let's assume that I have to first write a small function, which will just give me that the output that how many times a flight has been delayed. So there's a function, small function, which says find the late flight. It takes a data frame. And if you've not used DataBrave before, consider this as a table. It takes a table as an input, which has just flight ID and the minutes by which it has been delayed. And as an output, it generates flight ID and the number of times, the count when the flight has been delayed. So how will I write test for this? So first, what will I do is create some mock data. I'll say create a mock data as a list, and I'll say take these inputs and also create mock data output. Now in this example, if you see, this is an ID and this is the minute. So I've created that mock input, and similarly the mock output should be, that's what I expect, would be ID and 2 times this 104 has been delayed. 107 has been delayed 1 time, simple count. So then what I'll do is convert this mock data into a data frame structure which my function is expecting, any format that your function is expecting. And then once that is ready, now I call that function and it'll return the result. And then what I'll do is I'll simply assert whether the result that the function has returned and what I was expecting is true or not. So that's a simple way to test locally by creating some mock data. So in unit test, we normally do function level test where we kind of test transformations and we test small parts of the data product, and we normally pass one row or message, but we do not test the whole job or a driver. But then the next level of testing is component test. In the component test, what we do is we do a job level test and try to test things like does my job call the read correctly? Is my code properly inferring the schema? Are my reruns creating the same output every time? So we try to test the whole job in the component test. So again, let's take an example. For example, this my flight analysis, the whole job is actually reading data from some AWS S3 folder and writing data to some S3 folder. How can I test that locally? So what I'll do is when I want to write the test, so this is my test. Now what I have to do is first create an input file that my job is expecting. So I will create a test file, and this is actually stored locally. I'll create a data frame out of it, and then I'll create a bucket locally in my local environment. I'll write that input file in that S3 bucket. So my input is ready, not in the AWS actually, but the mocked AWS S3 bucket. Then when my function would be called, it would be expecting that there is an output bucket where it should be able to write. So I'll create an output bucket again locally. So that's a mock output bucket. And then what I'll do is just call my program. When my program is called, my job is called, it will read from this input path, which is here, and then write to the output path if that output path has been created. Now I have to verify whether the the output which has been created is as per my expectation or not. So what I'll do is actually go to that output bucket which I had created, assuming that when I call this program, it should have written the output file there. So I'll read that, create a data frame, and we'll check the expected output is equal to the output file. So here I'm not actually testing the smaller functions, but testing the whole end-to-end job, whether it is able to infer the schema, check whether the whole read is working or not. When we were showing this we were doing this component testing, I spoke about local environment. So there are a lot of containers or simulators available which you can use to mock the environments that you have been using. This is again one of the examples. So there's a local stack which is available through which you can mock the AWS environment, and for Spark you can use this particular image. So try to find the images or Docker containers or simulated cluster through which you can run your test locally. So if we look holistically, we start with the developer machine. In the developer machine, we should write unit test. And in that unit test, we are not actually mocking the files. We are just mocking row level or message level. Then we write component test in the developer machine. And then we use simulated cluster and you try to do test-driven development. Now, when this is done, commit it, and the same test should also run in your CI/CD pipeline, because you don't want it to be limited to your developer machine. It should become gradually sort of your regression test. Now, let's move further. Once your data goes to the pre-prod environment, there are two types of tests which are important. One is your flow test. In the flow test, you actually test a data product in its entirety, including its orchestration or choreography. For batch processing, you can use your workflow tools and cluster to execute the entire workflow. And for streaming, you can simulate a producer to generate events. And in lower pre-prod environments, this can run with mock data and can be scaled in with a volume that's higher than what we used locally and in the CI/CD pipeline. And in the later ones, you can always use prod-like data. The other type of testing is exploratory testing, which is actually used to catch quality issues that are not yet automated. And this can also include some sort of cross-functional concerns, like making sure no sensitive data is logged into the pipelines. Let's further move ahead. Now we are in production. Now think about the left side of production. In the left side of the production data pipeline, we should do data quality checks. Now, these are checks plugged into data pipelines to be run at runtime so that we do not run blind in production. They normally look like a field should only contain certain values, such as within a specified range. One field is less than other field or more than other field, or should be unique. So any quality expectations from the consumers or the domain owners are qualified or are codified in your data quality test. And it's better to test early before it reaches to the consumer and business finds out those issues and gradually loses trust. And the other type of test is anomaly detection sort of test. So it's gradually you can strengthen your pipelines by these. And the anomaly detection type of test are useful to see any issues, keeping historical context in mind, some sort of distribution you were expecting, you've observed earlier, which should be pursued later as well. But one important point to note is that these quality tests and anomaly detection can also be run in pre-prod environments where you have a sort of prod-like data so that we can get earlier feedback. It's not just limited to the production environment. Now, here is an example of data quality checks. There are various tools available, but Great Expectation is one of the popular tools we use these days. So here in this test, we are checking whether a column is particularly existing or not. We are saying that the max value of like this field arrival delay, it's between 1500 to 1600. The other thing we are checking is the 95% of the columns are not null. So sometimes when you're doing certain analysis, it's fine that some of the columns are null, but you want to maintain a certain percentages. There are other type of tests like aggregation, frequency distribution, mean, standard deviation, and correlation between the column, which based on your data you can also test. So when we talk about data quality test, you can always refer to this grid. Now, if you remember in the beginning, we spoke about the testing pyramid. So if you see this axis, this is your code testing pyramid. And if you see this x-axis, this is our data testing pyramid. Now, in this data testing pyramid, we have point, sample, and global test, which is point test are more around where you reason about specific cases like invalid values and all those things. In sample test, you basically quantify certainty, risk, or sensitivity with a sample. A model does not discriminate based on gender. And when we talk about global test, we basically talk about evaluating certain parameters on the whole data set. For example, a data pipeline produces the same count of output and as inputs, or maybe moving averages within the historical bounds or not. So use this practical data test grid to make sure that your data quality coverage is fully there or not. So apart from this testing, it's important to actually invest and understand in data contracts as well. So in the data pipeline, we produce data products. But if we think about the left side of it, we have a certain source. And if there's a certain source, there are data owners. So it's important to identify the data owners and have a data contract with them. In that contract, you should have contact information, understand their responsibility, make them responsible for the quality of the source, and in the contract capture the metadata information like schema and the format of data, and use it to validate the contract. So as the data comes into the pipeline, and if it is not as per the contract, alert them, use the contact information in the contract to alert them so that they can fix in the shared responsibility model before the low quality data reaches the consumer. So it's important to capture the contract, but also invest in logging, monitoring, and alerting so that they can be automatically alerted, and that it can be fixed before anything goes wrong. Now, we have spoken about a lot of things, but if you want to create an image, I would say that you can think of it as a ladder of reliability, where you have automated tests in your local and CI/CD environment. You have flow tests, exploratory analysis, anomaly detection, quality test, and contract along with data contracts, and all this supported by logging, monitoring, and alerting. And this will help you have more reliable data pipelines by testing and validating early, that is shifting left. Now, to conclude, I would say that there is no silver bullet and software engineering principles are still valid. We have to test and validate early, that is shifting left, and automation is our savior. We have to move away from untested, unstable, and undocumented, and shared responsibility model is critical for the success of data pipelines. And observability is our path to faster recovery. Thank you.